Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about the ratio of areas. Well, let's get started. All right, so if we have two polygons that are similar, then the ratio of any pair of corresponding parts is the same. So I'm going to say that triangle 1 is similar to triangle 2. So, all right, 1 similar to 2. So I know that the ratio of any pair of corresponding parts is going to be the same. And I've drawn all the relationships for you. So I have 3 to 4, 3 to 4, and also 3 to 4. All right, so let's talk about how that functions in terms of relationship of areas. So I'm going to ask you, and you can pause this for a second, what is the ratio of the areas if the parts are in a ratio of 3 to 4? What is the ratio of the areas of the triangle from 1 to triangle 2? All right, and the answer is going to be the square of the relationship of the sides. So here we have a relationship of 3 to 4. So the relationship of the areas is going to be 9 to 16. So why is that true? All right, so let's take a look at two equilateral triangles, and let's understand why the relationship is going to be not just the relationship of the ratio of the sides, but the relationship of the square of the sides. So we recall we actually did this problem before in a prior lesson. We had two equilateral triangles, one that had side lengths of 6 and the other that had side lengths of 18. And we figured out the respective areas of both. And we did that by dropping an altitude in both of the triangles. So let me go ahead and take care of that. And we ended up with two 30, 60, 90 triangles. So here's 60. Remember, the angles in an equilateral triangle are going to be congruent. So I have two 30, 60, 90 triangles. Here's 3. Height is 3 root 3. This is 9 and 9 root 3. So the area of ABC is going to be 1/2 of 6 times 3 root 3, which gives me 9 root 3. And the area of DEF is going to be 1/2 of 18 times 9 root 3, which is equal to 81 root 3. So the relationship of the side lengths is 3 to 1. And the relationship of the areas is going to be 1 over 3 squared, or 9 to 1 or 1 to 3, depending on the relationship or the order that you're talking about, referring to the triangles and the areas. Which leads us to our theorem 109. If two figures are similar, then the ratio of their areas equals the square of the ratio of the corresponding segments. So the area of one area over the area of the other in a similar figure is going to be equal to the side length of one over the side length of the other squared. And that's going to be the relationship of their areas now. So be careful if they ask for the relationship of the side lengths. It's going to be the side length to side length. If it's areas, it's side length over side length squared. All right, so just some practice to make sure that you got this straight. What is the ratio of the area of the two squares? And I'll give you a moment to figure this out. All right, so I have an area of 16 units squared for the circle, the smaller circle, and 49 units squared for the smaller square, and 49 units squared for the larger square, which is the same as 16 to 49. And that's what we get when we square the side length relationship. So 4 over 7 squared gives me 16 to 49. All right, a couple more problems for you. What is the relationship of the ratio of triangle 1 to triangle 2? So this is kind of a tricky problem for you. So why don't you think about this and then come back. Okay, so in this case now, I have two triangles and they both have the same height, right? The height for both of these triangles is this distance. So if the height for both these triangles is this distance, it's both the same, then the height is the same. The bases are the only thing which is different between the two triangles. So in the area of triangle 1, I have 1/2 of the height times 7, and that's going to be to 1/2 of the height, which is the same height, times 5. So if I divide both sides by 1/2 the height, I'm left with a relationship or a ratio of 7 to 5. So now it's if you have a common value in the height or the base, then you end up with a relationship that just corresponds to the base lengths in this case, which is 7 to 5. So be careful, don't always square the values that you get. You have to consider what other values you're using as part of determining the area of your figure. All right, now how about this one? What is the ratio of triangle 1 to triangle 2? All right, this brings us to and this is not another trick question, but brings us to theorem 110. The relationship of triangle 1 to 2 is going to be 1 to 1 because base 1 and base 2 are the same and the height of both of the triangles is the same. So the area of 1 and the area of 2, triangle 2, are both the same. And that theorem says that the median of a triangle divides that triangle into two triangles with equal area. So I have a median of the triangle. Here, base 1 is congruent to base 2. So the area of triangle 1 is going to be congruent to the area of triangle 2. All right, that's it for Rotten Math. Come back and join us for some practice problems on the ratio of areas.